All right. Okay, so we are kind of flowing into the second piece of, which is a bad word probably to use with a bunch of girls, but anyway, flowing. Anyway, we are going into the next phase. Remember, we started with the Riemann sum, but that was all leading to what we're going to talk about today, which is anti-derivatives. Okay? Anti-derivatives. So we talked about derivatives. What are you supposed to anti-derivative is? It's the opposite, right? Just like any anti-word is the opposite. All right? So this is the language that we're going to start with, and it's kind of got to evolve the entire way. So don't get too bent out of shape if we keep like changing the language. But for now, this is an interval, okay? And it is. We've talked about these kind of intervals where we had. This is a definite interval, okay? Where you had an upper and a lower limit, okay? This right here, this piece right here is called an indefinite integral, okay? Now look at the big F versus the little f, okay? The antiderivative, if this right here, I'll wait till you're done. This right here is the antiderivative. Then if we take the derivative of it, we get that, correct? That's how it works. Okay, now what happens is you're going to get real confused at the beginning because you're going to still want to do a derivative. You can check this. Once you get an antiderivative, you can check and say, oh, is that the derivative? Yes. Then that's the correct antiderivative. But I know how some of you all operate. If you don't check yourself, you're going to find derivatives instead of antiderivatives. So be careful. You're also going to see this like this, integral f prime of x equals, what would that equal? What would be the right notation? Big F has not been in our vocabulary till today. That's right, Kaylin. Good job. The derivative of f of x is f prime, right? So this, you'll see both this language, okay? But it means the same thing. You take the derivative of f of x, you get f prime. If you take the derivative of f, big F, you get f. Big F has to go away, okay? Because, but we need it for development of something for a while. But it's going to eventually, it's like big F, little f, come on, it's too much, okay? Yes. You take the derivative of f of x, you get f prime. If you take the derivative of big F, you get little f. Okay? That's how we define big F. But again, that will be going away eventually, but we need it for a while. Okay. So, f of x is x squared. All right, we're looking for what functions have f of x as a derivative, or in other words, what would be the antiderivative of x squared? Okay, Anna thinks she's got it figured out. And then most of you, usually this is the response I get. Even in AP, they kind of look at me like, well, how do I know that? Well, come on, you know a lot more than you think you know right at the moment. You know if I'm going to get a squared derivative, what's my function going to be that I started with? What's the, there you go, cubic. Okay. What's the rest of it? Because this is going to give us 3x squared. We just have a single x squared.
Oh, wait, would it be times 1/3?
Does that work?
Wait, would it be times
No.
1/3?
Okay, come up. Is the derivative of that?
I don't know.
Well, if it's, come on, you can do derivatives in your sleep.
Is it 1/3 x cubed?
Yes. It's this or this. Yes. However you want to express that, that's the same thing. Oh, smart.
No.
They are, you wouldn't be surviving if you weren't, trust me.
True.
Okay, now, I bet, all the smart people, just kidding, really though, could give me about a different one. Give me a different one that has the same, function as this. This is one function. Let me give me another one, come on. Okay, let me give you hints. What can I put on top of that? Not on top, but with that current thing, that the derivative of it would not affect this. A constant. So give me one. What's that? X cubed over 3 plus 2. That could be an antiderivative.
So my plus 3 could work, we just have to divide.
Yes. Okay, give me another one, Kathleen. These are all antiderivatives.
X cubed over 3.
Okay? Give me another one, Kaylin.
X cubed over 3.
All right. Okay? So we can all come up with a different one, right? As long as those are constants. Okay. So good job. Love that you used the good language. All right. The most general antiderivative of little f on the interval is f of x plus c, where c is a constant. Okay? So when they would say find the antiderivative of f of x equals x squared, you would write the most general, which would be, x cubed over 3 plus c. Okay, so you just put that c out there. That means any constant we can put in there, that would be. So when they say the, what's implied is the most general.
Plus or minus?
Nope. C is not necessarily plus just because we're adding it, right? But good point. Good thinking that it could be a minus, just like Kaylin gave us a minus one, right? C could be positive, could be negative. Okay? So far, so good? I get those sometimes too. All right. Find the most general antiderivative of each of the following functions. All right. Now, remember, I'm going to call AF because that's kind of how we defined it. But you could just write the function like we did x cubed over 3 plus c2. All right. Which function has a derivative of sign? That's what you're asking yourself. That's what the antiderivative is. So f prime equals sine of x.
Squared over 2.
Negative cosine x would take care of it, because if we take the derivative of the cosine, we get negative sign, and that would be like, oh, okay, that'll cancel it out. Don't forget, plus c. Okay? Again, you all, like I said earlier, you could do most of your derivatives, these easy little derivatives, in your sleep right now. Okay? So don't forget to check that derivative of that is that. If it's not, then you don't have the right antiderivative. Okay? All right, what about this? Let me write it better.
Something over radical x, right?
Okay, something over radical x.
All right.
ln x.
Number plus c.
Okay, you're very close. Excellent job. The most general is the absolute values. This is your antiderivative. And we never had that when we did derivatives, because eventually the derivative of this is this, the derivative of this is this. So we always went kind of to the default, but that's the most general. Okay? Radical, that would give us a half. We don't want a half, we want 1 over x to be the derivative. The derivative of this is that, correct? That's how. All right. Don't say it out loud on this one, because this is like the most important one, the one that we use the most. F of x equals x to the nth. All right, anybody think they know it? Lizzie? Nice. Very good. Is that what you were going to say, Hannah? Yeah. Emma? Good job. Let's see. Good work. Good job. Okay. Now remember, we did derivatives. We subtracted. Now you're adding. And then whatever this is, you're going to divide by it. So sometimes you're going to divide by 1/2. Sometimes you're going to divide by 2/3. Sometimes you're going to divide by 3. Just depends on what it is. Okay, but that's it. Good job. Well, because let's take the derivative of this. When we take the derivative, we're going to take n plus 1 and subtract 1, right? And what's that? Okay, and then if this is already here, that's a thing that's going to be divided over there. Sorry, I did a really bad job. Let me try that again. Okay, we take the derivative of this. This is a constant. So I'm going to just leave it alone and then take the derivative. Sorry. No. If it's 5x to the 5th, what happens to, this is the derivative again. You hang it around, and this is 5x to the 4th, right? Okay. So you're going to do that. You're going to pull around the function. This is going to hang around. So far, so good. Okay, this is what I'm doing. This right here is the same as this, correct? Huh?
How did you know that?
Sorry. Okay. All right. This is this. This is this, correct, Megan? Yes. Okay, now I'm going to take the derivative of it.
The derivative is x.
I'm going to pull that around. Yes. That's,
So how did you?
okay, I'm going to take this around. N plus 1, and now I have that n plus 1. And then I subtract by 1, and I get n. So that equals x to the n.
What I'm saying, how do you get the x to n plus 1 over this one just by looking at x?
I don't know, well, I mean, you see how it works, right? Because we just did the derivative here. So now you're just going to memorize this just like you memorize pulling it around and subtract 1. You're just now going to add 1 and divide by that number.
So this is like a formula, it's not something.
Correct. And it's any number. Yes.
Can I take a shot?
Yeah, give us a minute though, because not everybody has a chance to look at it yet. All right, so G prime. We're looking for G. Because it says find a function given its derivative. All right, and then there's a hint here, right, so that you can use this function antiderivative formula, if you will. All right, remember when we started derivatives, you're like, huh? It's going to be the same way with antiderivative. You really have to think about it. Plus, you are so used to doing the other. All right, I'm ready. Whenever you are, Emma. I did.
Okay, 5x minus x to the 4th.
So you're saying g of x is 5x
Minus x to the 4th plus 2/7 x to the
2
7th.
7
x to the 7th over your x cubed.
Okay. That was a nice idea,
But what about c?
but okay. Even if we put c in here, how can we find the derivative of this, people?
You know the.
Okay, did you try it?
No, I just remembered that, but the question, well, you take the one on the bottom. Oh, so you would have to do it.
Okay, so that works for that, so that was smart. Okay, does it work for this? I think she just did it individually, didn't she?
Yeah.
Okay, so we know that doesn't work because the whole quotient rule doesn't
But I
work.
got it close. That was
Yours?
off by
Yeah.
itself.
Yeah. Okay, you didn't take my hint. Right, so that you can use the power rule. That's what C is, power rule. For antiderivatives this time. Remember we had the power rule for derivatives, now we have the power rule for antiderivatives. Okay, so how can we do that? Let's just get rid of this. It was a good try, Emma. Okay? How could we write this as power, power, power? Three powers. Yes. Megan, do it. Okay. So if we split it up, now we can write that as, this is still G prime, I haven't done anything with it. 5x to the -6, good job. Minus 4x to the -3, good work. And 2, x6 is canceled. Okay, now we have power rule that we can apply 3 different times. All right, Kelsey, give me the first. What?
I don't know.
Sure you do.
No.
Sure you do. You're going to take this 5 and leave it alone, just like we did with the derivatives. You're going to add 1 to -6, and what are you going to get? And then you're going to divide by that number. Okay? And you're going to simplify.
Wait, that makes sense.
I'm glad.
Yeah, why didn't you buy
Because that's the power rule. Remember, x to the n plus 1 over that number n plus 1. So this is the derivative. Remember, when you take the derivative of this, the -5 will pull around. You will decrease that by 1. And then you'll have that, which will cancel each other out, and you'll have the x to the -6 that you want. Well, I didn't do it right because I didn't really need that. Okay, so what does that simplify to be? X to the -5? Negative x. Okay, now take the derivative in your head. You can do that in your head, right? What is it? 5x to the -6, which is what we want it to be, because that's what Megan said after we split it up. Right?
Yeah.
Okay. All right, I'm going to hang around the 4.
Why?
Because I can. No, that's not a good answer. That's a constant thing that we're just going to hang around with.
Oh, I
Remember the integral rule from last class? We said let's just pull that integral out. Pull that constant out, honey. That's what we're doing. Okay, what's the rest of x to the -3 antiderivative? X to the -3 plus 1, which is, and we divide by that same number. Once you figure it out, it's that same number down here. Okay, so now we simplify. We got plus 2x to the -2. Okay? Plus, what's the derivative of 2? Nothing. 0, derivative of 0 is 2.
That's over the impact.
Oh, sorry. Sorry, you're right. I asked the wrong question, didn't I? What's the antiderivative of 2? 2x.
I don't know what I'm doing. I'm going to alone.
The derivative of 2x is 2, is it not? Okay, is there an x that you can't see there? X to the 0. When we add 0, we get the 1. We divide by the 1. That kind of takes care of it. Okay? Plus. All right, now. This is g prime of x, right? If we take the derivative of this, we get that. We take the derivative of this, we get that. We take the derivative of this, we get that. Take the derivative of this, we don't get anything, which we don't want to get anything. And this, my friends, is g of x.
This is so.
First get used to it. Get used to
You're
it.
going to be like, on the final, you're going to be like, do a derivative. And then I'm going to be like, I don't know.
Well, you'll be used to that by the final.
Okay, this is integration.
This is integration, yes. Yes.
What is integration?
Integration, when we're taking and finding the values of integral.
I said immigration too.
Oh, sorry, okay. All right, so this is a partial list of some antiderivatives. Now, here's the thing. If you don't know that list of derivatives, you're going to have a hard time with antiderivatives because you're not going to recognize them, and then you're going to be like, I don't know how to do that one. There's a lot of them that you simply have to remember. All right, we already talked about this one. Okay, we already talked about this one. What's this one? Absolute value. Okay, that's the most general. Okay, because why do we do that absolute value for the most general? Because if we have a negative, we have a problem because this doesn't exist. So that's why you have to take the absolute value. Okay, what's that antiderivative of e to the x? Why? And when you take the derivative of the e to the x, you get e to the x. Take the derivative of c, you get 0. That's what we want. You just until you get used to doing it, you have to check yourself. And you'll get used to it just like you did the derivatives. All right, what's the derivative antiderivative, of cosine of x? Sine of x is the derivative sine cosine. Yes.
Yes.
Okay. Okay. Now, again, you're not going to remember. You're not going to remember because it's going to be like, oh, I can't remember negative. You're just going to double check. The derivative of sine is cosine. Done. You don't need a negative. Now, if you put cosine here, wait. The derivative of cosine is negative, so I got to have a negative on my antiderivative. Okay. Remember, the cos have negative derivatives. Okay. So it'll all switch now for antiderivatives. So just double check yourself, because that negative is going to kick you in the butt if you let it. Okay. When do we have a derivative of secant squared? Tangent. Awesome. Okay. All right. When do we have a derivative of secant x tangent x? Nice. These are all ones that you just got to remember. The derivative secant is that, derivative tangent is that. Okay. This could go a couple different ways. What's the simplest one? Cosine.
Inverse cosine.
Inverse cosine?
No, it's inverse sine.
Okay, let's talk about this one. Is this this? Is the derivative of this this? You should know it. You better get another pink sheet because you're going to need it. So that's the most. Okay, what about the people that wanted to do inverse cosine? Because they're pretty close. Yeah, then you have to put the negative. So this is the simplest, but either one is going to work. All right? Does anybody need to hear that again? Remember, just double check yourself. The derivative of that is that. The derivative of that is a negative that, so I got to put my negative on my antiderivative because I can't switch my derivative. It is what it is. Okay, what about 1 plus x squared? Good. Okay, now is there another one that's closely related? You could do negative inverse cotangent too. Again, if you can avoid the negative, that would be preferable because it just makes it simpler. Okay, these two we don't remember very often, but we don't use very often, but who remembers them? Bottom one is cotangent x. And what about the other one then? What's that? Okay, is this one negative? Yes, because it's a co. And this is cosecant? Is it negative? Okay. All right, so that's, you're going to have to do a couple antiderivatives right now. We're going to keep it pretty simple. You're going to know this one. You're going to have to use that one pretty frequently because that's a polynomial one. This one, I'm going to write that one separately. And then the other piece is to recognize the common derivatives. Okay? If if it's not this or it's not this, you might have to do some manipulation to create that or that. Okay? Let me give you an example of a manipulation. Okay. This is the same language. I'm sorry. Am I getting ahead again?
No.
Okay. I do that sometimes. Okay, this is an example of a manipulation. Okay, remember this is the same thing as saying find the antiderivative of this. Okay, that says the same thing. Or okay, so they would have the same answer because it's just a different way of writing it. An indefinite integral of 1 over cosine squared, or find the antiderivative of 1 over cosine squared. Now, you won't find cosine squared anywhere on the list, but what will you find? Something that's squared that's the same thing as cosine squared. 1 over secant is the same as 1 over cosine? Secant, that's right. That's 1 over cosine, good job. Thinking about the reciprocal functions is the same as secant squared. Secant squared was on our list of common derivatives, right? So what's the antiderivative of secant squared? Tangent x plus secant. Okay, so that's a manipulation that you're like, wait, oh, that's the same as that, so that's a common one. There you have your antiderivative. So if you don't recognize it, see if you can switch it up to see that it will be on the list. The list is the same. We're not adding to that list. That's all we got in Calc 1. Okay? Calc 2.
Like Calc 5.
Yeah, there's Calc 4. Then you start calling it something else. What do you call it? Differential equation. Okay? Any questions? Ready to, all right. Okay, so I already talked about this. Indefinite integrals. That's an indefinite integrals. It's the same thing as an antiderivative. Okay? They are interchangeable. Okay? So this is all the same. Let's try one. Set x to the 4th minus 2 secant squared x dx. We want the antiderivative, or we want the indefinite integral. Same idea. All right. Yes, they are interchangeable words. Antiderivative. You'll see them both. Okay, who wants to give me the first part? You're going to separate these like you should. Kat?
Can we simplify it?
Sure.
Would be 2x to the
2x to the 5th. Now, everybody can do the quick derivative and get 10x to the 4th. Good job. But we started, we saved our 10, and then we took our x to the 4th, we added 1, and we divided by that same number 5. And that's where Kat got 2x to the 5th. Good job. Okay? All right. Minus, again, we're going to save our 2. And there's our secant squared again. Tangent. So, can't do anything with that. And don't forget your C. Okay? You take the derivative of this, you will get that. Yes,
So
make
can
it.
you just use 1c?
Yes.
The whole thing's good.
Yeah, because a C plus another C is still a constant. So, yeah, you don't have to go crazy and add C1 and then C2. Yes, Emma?
When it gives you a function, it's like means on this equals what?
So this would equal, if I'm understanding, this would equal f of x.
Yeah.
This is little f Okay, or sometimes they'll call that, yes, 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 good question. This is sometimes called big F, and then that would be little f. The language just keeps, and you know, remember that from derivative, it changed frequently too. All right, go ahead and try that one. It's real easy to check your derivative when you're done. Then, forget anything? Me too. Skip. A lot of hair. Good idea. Very good, Kat. Don't forget your C. All right, good job. Okay. Hold on to the 6. Remember, add 1. What's the current exponent if you don't see it? 1. So add 1 to that. Divide by that same number. There you go. And then simplify. Look at your sheet, otherwise you're good. Yeah. Okay, did you forget something? And you forgot the C. All right, that's good. Okay. Okay, so we're taking X, we're adding a 1 to that, that's 4, we're dividing by that 4. Okay, the 6 is hanging on, we're adding a 1 to that current 1 and dividing by that number. You can leave that, you can write it like this, either way is okay, whatever you prefer. I just do this, but some people would prefer that. And there's your answer. Okay? If you're doing, typically, if you're doing a indefinite interval like this equals this. You don't have to name it. If you have to name it, that's a kind of a different way of saying. Okay, let's try this one. Okay, this is a little bit extension. Yeah, okay. So first, we're looking for F, and we are given F prime. All right, so find the F first. Don't forget your C. Find the F, as in find the antiderivative of F prime. And I wrote it maybe how you didn't expect it to be written. I can give you a little hint if you get stuck here. You don't have to add C twice. You just add it once and you're done. You don't have to add a C just because you're doing it individually. You don't have to. You don't want to add it twice because a constant plus a constant is still a constant. Where'd you get to one? Oh gosh. You can't do that with that -1 down there, darling.
You can't move it to the bottom?
Yes, you can move it to the bottom, but she distributed the 20, and that's not really going to be. This is this. Okay. So I haven't done anything. I just moved that to the bottom. First part simple, right? What's the antiderivative of e to the x? E to the x. We'll add the c back here and we're done. Well, -1 means that, does it not? For those of you that as you can, that's not like any special move. Okay. Is it what? You sure? Anybody have it?
Is it -20 times 1/3 x cubed plus x?
-20 times, say it again.
1/3 x cubed plus x. Oh wait,
That's all going to be that?
no.
She regrets that answer. All right, delete. All right, I'm going to give you a hint here. Wait. Anybody Got it? I'm gonna give you hints. I won't say it.
No. Oh, I know, right?
Now you see it, don't you?
Already got it. Sure.
Did you really have it?
Yeah.
Good work. You kidding me? But see, you have to put it in the form that you would recognize it. We didn't recognize it underneath that 20. So what is it, Kenzie? Nice. This is just hanging around, just like it did on the derivative. You just pull it around, and then this, the antiderivative of this, is tangent.
Wait, what if I did?
Interesting.
What if I did quotient?
Why would you do that?
I don't know, because I'm still doing derivatives and all that.
Right. You don't want to do quotient rule for derivatives. Okay? Remember to take the derivative of this to get this. You don't have a quotient there, darling, is what I'm saying.
I know.
Okay. Okay. Can you all believe Miss Cook is going to turn 70? Miss Cook's an IT lady.
Yeah, she's 70.
Yes.
Dang, she's not.
I know. I got the
Is it? She's not that old.
No.
I think my grandma's.
Okay, so any questions so far? All right, e to the x, or f of x. Now, what the heck? This means we're going to fill in the C. We have some specifics. F of 0 equals -2. So f of 0 means, what is that 0? Going to be placed, right, we're going to place the 0 for the x, replace, rather. And that, according to up here, is -2. One long statement. I plugged in f of 0, which means plug in your x, 0, 0, and that equals -2. That comes from here. Okay, how about anybody? All right, what's e to the 0? 1. What's inverse tangent of 0? Where is their tangent 0? Tangent is sine over y, right? Sine over x? Sorry. Sine x over cosine x. All right, so is it here or here? This is 0, 1. That would be 1 over 0. Is that 0? This is 1 over 0. So it is 0. Plus c equals -2. That's gone. 1 plus c equals -2 with c. -3. Okay, so now we have a full-on f of x, which is e to the x plus 20 inverse tangent of x minus 3, because we put in our c. Okay? You can check it, it'd be kind of, you could check the first part easy enough, but then you'd also have to check the f of 0. You have to put the 0 back in. I already did that. So I don't really anticipate that y'all are going to do that, but you could if you wanted to. Okay? Any questions about that? All right, let's try another one. We got one more that we can do. We have f double prime. We have f of 4 equals 20. We have f prime of 4 equals 7. All right. If I do this, what is that going to give me? Good job. Okay. So I'm going to do 3 radical t. A dt is just a. Now, do you understand why we have a dt? That means that's reminding you that this is the derivative. D is a derivative. Remember when we use the related rates? D was always the derivative, so that's kind of where it comes from. All right, let's make this easier and put t to a power. What is that power? -1/2. Okay, now it's a super easy problem to find. It's good just to keep it You could probably shortcut some of it, but you're going to get confused about what you have if you don't identify it.
All right, so who can give me the antiderivative of 3t to the negative 1/2? Everybody yell. Go ahead, Megan. T, you mean?
Oh, yeah, there's
3t.
uh,
Wait a minute, are we not going to add 1 to negative 1/2?
well,
Well, there's only one way to do it.
isn't 1 over
No, not radical. Okay, we're going to use the power rule. Do it, Claire.
Okay.
The 3's just hanging around. Power rule. Good. The same number. Now, when you divide by 1/2, what are you multiplying by? So I'm just going to put that 2 right there. And you can get used to doing that right away, so you don't have to have that ugly 1/2 down there, or you can do it later. Okay? So that's plus C. So let's clean this up. What does that really look like? 16 to the 1/2 plus C equals F prime. Okay? F, no, we gotta go backwards again. F prime equals 7. F prime of 4 equals 7. So what should I do now? F prime of T prime equals 6 T to the 1/2 plus C. I'm just spelling everything out here. All right. F prime of 4 was what? 7? So what is that up there? Okay. So I'm going to plug in 4. 4 to the 1/2 plus C. All right. What's 4 to the 1/2? Square root of 4 plus C equals 7. C equals. Okay. We'll pick that up. Equals 1. That is equals 1. Easy.
That's just like, it's too long.
Yes, at the end of the semester, we will decide.
Okay, you just like drop our little. This one is so definitely. You have to sizes. Oh, I'm sorry. Changing the word. Oh my God, it's called.
I couldn't turn on this morning. It just like, oh, now it goes on. Okay. So we got F prime and T, right?
You don't get goosebumps down. No, you don't get goosebumps in your hair. Like, oh,
All right. Oh my gosh. I'm going to turn this to go on. I was just telling us, yeah.
Don't tell her to figure it out.
Oh, yeah. Okay. There's only one down, right? Okay, so let me tell you what F prime is. 16 and a half minus 5. Okay. Because remember, here was F prime and T without C. All right, that's a lot of work. Now we still aren't done because we're still looking for F. What don't we know? Oh, we don't ever, we're not even interested in T. We're interested in F.
I thought we were interested in C. Momentarily.
Okay, we're interested in F prime right now, which is that. Now we have to find F. Okay? So what's the relationship, everybody ready? Between F and F prime. How do we find F? Good. Yep. Now let's put it in. 6t to the 1/2 minus 5. All right. So F of t is what? 6 t to the 1/2, 3/2, right? Times, divide by half, it just times by 2.
Wouldn't that be 3 halves on the bottom?
Yes. Thank you. Divide by 3/2. Okay. All right. Minus t plus. Okay. Are you talking about me?
Because she doesn't say to stop.
It's probably like right. So what's that? Okay. What do we know about F? F of what? Equals. Okay. All right. Close. So some of these these back here are like this. But you know, we start F double prime, then with F prime, then F. So okay. All right. 4 to the 3/2. Remember that's the square root cubed. Okay. So what's the square root of 4? 2 cubed is? Okay. Five times 4? Plug it in.
Oh, so did you just slide us for?
Wait.
No, no.
All right. Ready? All right, Emily.
4 to the 3/2 minus 5 to the
Final answer. Phew. No. Okay, stop the recorder, and then I gotta figure out.